We're going to continue our discussion on complex numbers by looking at adding, subtracting, multiplying, and dividing them. Start out with a basic example of adding two complex numbers together. Notice they're both in the form a plus bi and a plus bi. Now the plus here could be a minus because it's basically plus and negative 7, but so it could be plus or minus there. Okay, now when we add or subtract or multiply, again, I mentioned this in the last video, you're just going to treat these like polynomials. Treat the i's like a variable. Okay, so when you add polynomials, you would just combine like terms. Same thing for complex numbers. You add the real parts together and the imaginary parts together. So here I would take the 2 plus the 5, add those together. I would also take the 3i and the minus 7i and add those together, and then just combine like terms. So this becomes 7 minus 4i when you combine them, right? 7 and minus 4. Alright, so in each of these examples we're simply combining like terms. I'll do maybe one more here. If we did 5i plus negative 3 plus 6i. Right, so here's an imaginary number and a complex number added together. Again, you're just going to combine like terms. So the negative 3 doesn't combine with anything. The 5i and the 6i just add up to 11i. Okay, so not too crazy on those. The subtractions are going to behave just like subtracting polynomials. So if we had 3 minus 7i minus 4 plus 6i, then I want to distribute the minus first, changing both signs on the right. So this becomes 3 minus 7i minus 4 minus 6i, and then we combine like terms. 3 minus 4 is negative 1, negative 7 minus 6 is negative 13i. Right, so just combining like terms, it looks just like working with polynomials. It gets a little bit different when we start to multiply these things. So let's take a look at an example of multiplication. Let's look at, let's see, multiplying the i's. Let's do 3i multiplied by 2 plus 4i. Okay. Well, this is a single term, a monomial times a binomial, so we're going to use the distributive property. That's going to give us 3i times 2. We combine the coefficients, that's going to be 6i. 3i times 4i is going to be 12i squared. Right? I times I is I squared. Now we did see earlier that the I squared, anytime you see I squared, that thing is actually equal to a negative 1. So what we're really looking at here is 6i, and then you get 12 times negative 1 is really minus 12. So 6i minus 12 is the actual complex number. And really, when we write these out, we like to put them in the form a plus bi. So I'd probably switch those around and write it as negative 12 plus 6i. Okay, just so I get the real part first and the imaginary part second. Alright, let's look at a couple of complex numbers in the form a plus bi. Let's do 3 plus 2i times 4 minus i. So here again, distributive property, or what some of you call the FOIL method. We could do 3 times 4, that would give us 12, and then 3 times negative I, that's going to be a minus 3i. 2i times 4 is 8i, and 2i times negative I is negative 2i squared. Once again, the I squared, this guy right here, is actually a -1, and so you've got to change the sign on that term essentially. So if I want to finish this off, I might write this as 12. Now I can combine the two terms in the middle because they're like terms. That's going to be plus 5i. Then -2 and -1 make a +2, so it changes the sign of that term. Again, I combine the real parts and I get 14 plus 5i. Okay. Alright, let's try a couple more of these. One of them, we'll just, maybe we'll square a complex number. Let's take 3 minus 5i and raise it to the second power. Well, remember, anytime you square something, you're multiplying it by itself. So it's 3 minus 5i times 3 minus 5i. And then using the distributive property, 3 times 3, that's going to be 9. This product is -15i. This was also -15i. And this one is positive, right, double negative, 25i squared. Now when I combine my like terms, in the middle here, I get 9 minus 30i. And then again, this I squared is really equal to -1. And so -1 times 25 is -25. If I want to write that in standard a plus bi form, 9 minus 25 is -16 minus 30i. Okay? Awesome. Last example, and this is one of my favorite examples or types of examples for complex numbers, and that is going to be multiplying two conjugates together, like 2 plus 3i times 2 minus 3i. Remember when we did factoring, we looked at conjugates. In fact, when we did some multiplying of radicals, we looked at conjugates as well. And what's nice about this is that when you distribute here, you get 4, you get minus 6i, you get plus 6i, and then you get a minus 9i squared, right? Positive, negative makes negative, 3i and 3i make 9i squared. Then we combine the middle terms, but those actually just drop out, right? They add up to 0 because they have opposite sign. And again, the I squared is equal to -1. So -9 times -1 is plus 9. The i's are gone, right? The i's in the middle canceled out. The I squared became a -1, and when I add these together, I just get the number 13. What's really nice about conjugates is that the product of complex conjugates will always be a real number. That's a very important point to remember.